Alright, this is 6.2, the law of cosines. We've been solving problems in which they've given us, to start with, they've given us an angle and a side opposite that angle, or a way to find an angle that is opposite a given side. One of those two situations. And so we set up the proportion, and we cross-multiplied, and we solved for the missing. But in this problem, if I had a problem like this, where I was looking at some navigation or vector problem, I'm not given the side across from an angle, and I'm not given enough angles to be able to find another angle that would be across from a given side. So in this particular instance, I'm given side, angle, side. So I can't use the law of sines. I mean, if I try to set one up, I have the sine of 65 degrees over x is equal to the sine of r over 12. Well, it's too many variables. Can't do it. So I can't use the law of sines to solve problems in this way. But I can use another law that will enable me to find the missing sides of this triangle. It's called the law of cosines. So you notice that the law of sines, this seems obvious, but you'd be surprised. The law of sines has sine in it. The law of cosines has cosine in it. Okay, so here is the law of cosines, and I'm going to write it out in different forms. And then let's take a look at the triangle first. And I'm just going to use ABC because it's familiar, but remember that ABC is not magic. Alright, so the law of cosines would start with a side, one of the little letters. So I'm going to start with this letter, a squared. And a squared is going to be equal to the other two sides, added together, squared and then added together. So b squared plus c squared minus, and it looks a little bit like Pythagorean theorem, but it can't be because this is not a right triangle. And then I'm going to subtract 2 of those same sides, b and c, and then take the cosine of the angle that's across from the given, the cosine of angle A. Right, so what we're looking for is a pattern here. So the proof of this law is on page, I wrote it down, 468 in your book, if you want to take a look at both the proofs, 468 and 469, the proofs of these formulas. Alright, so what if I start with a different one, like say I want to start with b squared? Well, all the rest of this is going to culminate in the cosine of angle B, because these two will be across from each other. These other letters will be the other two sides, whatever they are, times cosine of B. And then once again, c squared is equal to a squared plus b squared minus 2ab cosine of angle C. And so, really, they're not three different formulas. They're the same formula. They're just written in a different order. So if you'll kind of decouple this formula from the actual sides and think about their position in the triangle, it makes this formula a lot easier to remember. So this out here is going to be a side. This is going to be an angle. And it's the law of cosines, so this will be cosine. Alright? So let's do an example. Okay, here's my triangle. As promised, I've given you a different set of letters than ABC, and I've kind of given you a hint that this is side, angle, side. But let's go ahead and write the given information onto the triangle. So angle M is 115 degrees. Not drawn to scale, obviously, because 115 is obtuse. Okay. Then we don't know the side across from it, but we do know that W is 10 and B is 15. That's hard to see. 10 and 15. Alright, so once again, we cannot use the law of sines because the law of sines would mean that I need to know what M is, or I would need to know one of the two angles, and I don't. So in order to find one of those things so that I can use the law of sines, I'm going to set up the law of cosines. And since I already have an angle, I'm going to set this up for m. So I'm going to have m squared is equal to, what are the other two sides? Well, 15 squared plus 10 squared minus 2 times those same sides, cosine of angle m, which I know, a known quantity, is the cosine of 115 degrees. All right, then this becomes a calculator problem. So m is going to equal, in your calculator, 15 squared plus 10 squared minus 2 times 15 times 10 times cosine of 115. Just type it in exactly like it is. Okay? And when you do that, take whatever that is, because I don't have it written down because I'm going to do that differently. I want to take the square root of both sides. So m is going to equal the square root of that, and what you could do is, since you have this decimal in your calculator, you could hit second answer, which is the minus sign. So you would find that a and s, right? Second answer. So take the square root, so you would have, that's a calculator thing. I don't know how to show you that on here. But second squared, second answer will get you the answer, or just take the square root of it, and you'll get 21.255. So what did we find? Well, we found a side, 21.255. Now, one thing I want you to see here is that this side, the longest side, is across from the biggest angle. It's across from the biggest angle in the whole triangle. And I don't need a triangle to see that. I could see that if I had 115 degrees, that's obtuse, then that side across from it has to be the longest side. I mean, it works in right triangles, it works in any triangle, that you can order the angles by the length of the sides. That's there, all right? So to solve the triangle, remember what I needed to find was I needed to find side M, which I found. I need to find angle B, and then I need to find angle W. Okay, this is what I need to solve. And all I have so far is side M, which is 21.3. Okay, so now if I have side M, M is across from something, I can use the law of sines. All right, so I would say that the sine of 115 degrees over 21.255 is going to be equal to the sine of B over 15. Okay, so when I take 15 times the sine of 115 and divide it by 21.255, then the sine of B is going to equal 0.639596. Is that between -1 and 1? Yes, it is. So that's going to be a valid angle. I'm going to hit second sine. So I need to take the inverse sine of the ratio to get angle B. And angle B will be 39.76, or about 40 degrees. And to find the third angle, I'm just going to do a simple subtraction. 180 minus 40 minus 115 degrees, and that's going to equal 25 degrees. And our triangle is now solved. So another example would be if they give us all the sides. Obviously, we need to find angles here. And I really wish this picture wasn't here, because the question says, find the largest angle to the nearest tenth of a degree of a triangle whose sides are 9, 12, and 18. Well, looking at those three sides, where is the biggest angle? What's it across from? The biggest angle is going to be across from the longest side, which is 18. So right here, I have the biggest angle is going to be B, angle B. Okay, so to set this up, then, I would say the side that I want is here. So I'm going to start with 18 squared is equal to the other two sides, right? 12 squared minus 2, 9, 12, cosine of b, or x, or whatever you want to call it, but that's the angle. Now, for some reason, this type of problem to solve is harder for students than anything else we do in this chapter except maybe bearings. And it's just algebra. That's it. It's just algebra. So I'm going to write these steps out slowly so that you can see what I'm doing here. Okay? But I'm going to take, these are add, these right here are adding. So to get them to the other side, I'm going to subtract. So I do 18 squared minus 9 squared minus 12 squared. And I'm going to get an actual number for that. And I'm just going to write the rest of the problem here. I'm going to take this in pieces. Okay, so this, when I multiply or subtract all that, I end up with 99. And that's equal to negative 2 times 9 times 12. 12 cosine of b. All right, now this part right here is all times. Negative 2 times 9 times this. Well, what's the opposite or the undoing of multiplication? Well, it's division. So I'm going to divide 99, but I want it to obey the rules of order of operations. So I'm just going to put it in like that, and that equals cosine b. Well, if I'm taking cosine of b, it needs to be in the range between negative 1 and 1. So when I do this, I get the cosine of b is equal to negative 0.4583. Does that make sense at all? Well, let's go back to the Cartesian coordinate plane, right? And let's talk about cosine. Cosine in the first quadrant is positive, right? Positive. What is cosine in the second quadrant? Well, cosine in the second quadrant is not positive. It's negative. So all the angles in the first quadrant are acute. And all the angles in the second quadrant are between 90 and 180. So they are obtuse. So if my ratio is negative, that means that angle B is obtuse. It's bigger than 90, less than 180. So when you do the inverse of this ratio to get the angle is going to be 117.3 degrees. Does this make sense? Sure, because cosine is negative, B is going to be obtuse. B is the largest angle in the triangle because it is across from the longest side. Okay? And that's all it asks for here. It doesn't ask you to solve the triangle. So this is all the part that you have to do. But if you'll understand some of these concepts and how they all fit together, it will make these problems a little easier than just memorizing a procedure. Okay, these problems are calculator practice, and I already noticed something wrong with this second one right here. I had two unknowns. So what I did is replaced b squared with 30 squared so that you can work it. And these are just calculator problems. So for instance, a would be equal to the square root of all of this, right? Put in here. And so then you would write down an answer for that. So I want you to work these using your calculator. Remember that this one you're solving for an angle, and so you're going to have to do the second thing on that. And if we have some issues, bring it to class. And then I want you to work this problem right here, page 421, number 3. It's the first problem in your homework. And I'd like you to solve the triangle using the law of cosines and then the law of sines. Okay, see you in class.